Good evening and welcome back to the channel. Today we are going to carry on or continue with our lesson on congruency. This will be the final part of congruency before we start with similarities. Part 1 and part 2 is already on the channel. First part is where I explain the conditions of congruency. Second part is where I show you how to apply the conditions. And in today's video, we are going to work with congruency, but on a higher level of questioning, as well as how to answer those questions. So first of all, we will be looking at the following. So I will do 1 or 2 questions for you. This is just to conclude our part on the congruency of 2D shapes. So the first question says, in the diagram, it's going to be ECB bisects. So they say bisects ACD at C. Okay. Then I also tell you that ED is parallel to AB. Okay. With that, they then say, question A, that they want you to prove that ACD bisect, oh my goodness, bisect EB at C. Then the second question they're asking is to prove that ED is equal to BA. The sketch that they give you looks as follows. And they label it accordingly. So A, B, C, D, and E. They also put 1 and 2, and they put these markings in. Obviously, they then show you that ED and AB are parallel to one another. Okay, so those are the 2 questions we're quickly going to look at with regards to this sketch over here. Remember, doesn't matter what happens when you're working with these shapes, you always do statement reason. So I'm going to do statement reason on the right here, S and R. Obviously, you write out statement reason accordingly. Okay. So if you look at that first question, they ask you to prove that ACD bisects EB at C. So ACD cuts. So they're basically asking, prove that this line cuts line EB at C. And the way that you do that is simply by congruency. But now this is where you need to be awake. You need to see that they've already given you AC and CD. So therefore you can say that AC is equal to CD. And that's given to you. It's given to you by what? By these markings over here. Okay? Now you need to go and think, because remember when I started with congruency, I told you that you needed 3 facts, 1 condition, and a conclusion. So you need 5 things. So this is one of the 3 facts. Where you need to be awake now is the following. You see that these are parallel lines. Okay? And you can see that the Z shape is provided there, and the Z shape is provided over here. Okay? Which means, if these lines are parallel, then these angles should be alternate angles, because they lie in between the parallel lines on opposite sides of the transversal. So therefore AC, or rather angle A, is equal to angle D. They are alternate angles because ED is equal to AB. Alright, sorry, not equal, parallel. Almost made a mistake. I do apologize. So these two angles are equal. Then you'll see that the Z shape is over here. So angle B should be equal to angle E, which are also alternate angles because ED is parallel to AB. So these two are also equal to one another. Okay. Now I've got my three facts. The method I used was the side angle method, the SAA method. Okay. And the conclusion states that therefore triangle CDE is congruent to triangle CAB. Remember to always write your conclusion, to have the corresponding angles together. C was written first, A and D second because they're corresponding, and then E and B because they are corresponding. Okay. Now, because you've proven congruency, it means that these shapes should be exactly the same. Okay, which therefore then means that side EC is equal to side BC. And the reason therefore is because triangle CDE is congruent to triangle CAB. So what I'm trying to tell you there is because these two parts here, this side and this side, are equal in length. This side AD is cutting through it, okay, bisects it. So in order for them to be bisected, these two need to be equal to one another. That is basically what they're asking you. So because those two are equal, yes, therefore they do bisect. Then, this is question A. Question B asks you, prove that ED is equal to AB. Okay? And you can say, yes, ED is equal to AB or BA because I've proven congruency, because CDE is congruent to triangle CAB. And because these triangles are congruent, then therefore these sides will be equal to one another. Okay? There you go, you solved that question as is. I'm going to do one more question for you and then we'll conclude the video for this evening. This was just to assist you with the types of questions that they will ask for congruency. Okay, so what I've got here is they say in a diagram, so this is for the second question. In a diagram, O is the center of the circle, passing through A, B, and C. They then say AB is equal to AC. Sorry guys, I'll be with you now. They say AB is equal to AC. They ask you then to prove that, so prove the first question, so question A, that angle O1 is equal to angle O2. Then I ask you B, AO perpendicular to BC. And then in question C, they ask you to prove that triangle ABC is a right angle triangle. What am I doing? Triangle. Okay. The sketch that they give to you is a triangle like this. It's got a line through. It's got two markings. And then with that, it's got a circle that passes through like this. My circle is not that good, but yeah. Then they mark this 1 and 2. They say this is A, this is O, this is B, and this is C. And then we've got 1 and 2 at the bottom. Okay, first of all, this question asked, prove that angle O1 is equal to angle O2. Now, the way that you can prove this is in the following way. I just want to put all of this here. So the way that you can prove this is by doing the following. You need to do congruency with your 3 facts and all of that. So statement reason is first thing that needs to come up, statement reason. Then we need to start with the following. First thing they said is that angle or side AB is equal to AC. Okay? Now when we prove congruency here, we're going to have to work with what we've got. Now you need to understand that this is the radius. O is the radius. From O to C, that is the radius, and from O to B, that is also the radius, which means that this would be the center point of the circle. Okay? From here to there, and from here to there, the distance should be exactly the same length. So, let's start with congruency. This is for question A. So, side AB is equal to side AC. And the reason there is that it's given. They gave it to you already. They gave it to you in the question. Then, another side that you can work with here is AO, because it's a common side. So AO is equal to AO, and that's a common side. Then you can work with side BO and side CO. So BO is equal to side CO. And the reason for that is because it's got equal radii. And the reason for it being equal radii is because this is the center of the circle, like I've explained to you. And from the radius to the circumference of the circle, either side, the length will be exactly the same. Your method that you used here was triple S method. So therefore, triangle ABO is congruent to triangle ACO. And there you go. You've proven congruency, which therefore means, because I've proven congruency over here, therefore angle O1 is equal then to angle O2 in this case. And why do I say so? Because of the fact that triangle, that doesn't look like a triangle, that triangle ABO is congruent to triangle ACO. That is why these two are the same. So there you've proven the first one. Then for question B, they asked you to prove that AO is perpendicular to BC. Okay? Now what you can do is you can say that this is a straight line. So therefore, angle O1 plus angle O2 is equal to 180 degrees. Okay? And the reason why they 180 degrees is because they are adjacent supplementary angles. So adjacent supplementary angles, remember, straight line with a common arm which shares the same vertex. Then from there, you can also say that angle O1 is equal to angle O2. And the reason for that is because it was proven. How was it proven? It was proven in the previous question with regards to congruency. Then, therefore, you can say that these two angles, angle O1 is equal to angle O2, and both of them are equal to 90 degrees. Okay? So because both these angles are 90 degrees, therefore side AO is perpendicular to side BC. Remember, perpendicular lines meet at a 90-degree angle. And there you've solved question B as well. Okay. Question C, I'm going to do over here. Let me just block this off so that you can see it's not part of that. For question 3, they ask you to prove that ABC, or triangle ABC, is a right angle triangle. So, the first statement that you're going to do, or going to make, is the following. So you are working in triangle ABO. ABO, we're working in that triangle. And the first statement that you can make is that angle O is equal to 90 degrees. Okay? And how do we know that? It's been proven in the previous question, so it's proven. Then you can make the statement that angle A is equal to angle B. Okay? Angle A1. A1 is equal to angle B. So angle A1 equal to angle B. And the reason why you can say that is because from the middle, from the center of the circle to the circumference, both these lengths are equal. So whatever happens here, they should be equal. So they are, what do you call it? They are angles of equal radii. Angles of equal radii. So because they've got the same distance going from the center and the hypotenuse closing the two, these two angles should be exactly the same. Okay, which then tells us the following, that A1 and B1 are both equal to 45 degrees. Because this is 90 and both of them are equal, you say 90 divided by 2, which makes this 45 and which makes that 45 degrees. Okay, and the only way that you understand or get that is by the sum of the interior angles of a triangle. Then, to continue, let me just see what's going on. Okay, so now we're working in triangle ACO. In that triangle, you can now also say that angle O2 is equal to 90 degrees, and that was proven in the previous question. With that, you can then say that angle A2 is equal to angle C. Just like we did here, angle A1 equal to angle B. So, and the reason there would be also angles of opposite equal radii. Then, therefore, you can state, because they ask you ABC, remember they gave you two triangles, but they're asking you if ABC is a right angle triangle. So it means that A needs to become a right angle. So therefore, at the end, you can then say, therefore, angle A1 plus angle A2 is equal to 45 degrees plus 45 degrees, which is equal to 90 degrees. Okay? And the reason for that is because the fact that A1 and A2 are 45 degrees is because you proved it by doing some of the interior angles of a triangle. And by proving that A1 and A2 is in fact 45 and 45 degrees, when we add them together and they give me 90 degrees, I can then say that triangle ABC, so therefore triangle ABC is right angled. So it is a right angled triangle. So this triangle over here is a right angled triangle. because I proved that these were 90 degrees and these would now become 45, 45, and the same on the other side, then these two together, added together, the 45 and the 45 will give me a 90, which means that this becomes a 90-degree angle. And then from there on, you can then state that ABC is a right angled triangle. Well guys, that is how we are going to conclude the sessions on congruency. We'll do more congruency when we do paper discussions with regards to your cycles and so on. But until then, stay tuned for our following videos on similarities, and that is also what we will conclude term 3 with. Stay tuned for discussions on papers to ensure that you are ready for your cycle exams. Until next time, make sure you let your friends know to pop in and subscribe, and then we will talk all about the next topic. Enjoy your day further. Bye-bye.